Hello dear students, welcome to Electronic Sparks channel. This channel is related to electronic subjects. So now first we are going to learn basic electronics engineering, which is the first year subject, and this series is related to the Sppu 2024 pattern. So now learn about unit number 1, which is diodes and its application. So most important application of diode is rectifier circuits. So let's learn about it. So what is mean by rectifier? काय आहे rectifier? So rectifier, it is the electronic circuit which converts AC to DC. Okay, AC means alternating current into DC means direct current. So it is the circuit which convert AC into DC. There are mainly two types of rectifiers. First one is half wave rectifier. Second one is full wave rectifier. So half wave rectifier and second full wave rectifier. Full wave rectifier is again classified into two main rectifiers, that is full wave center tap rectifier. Okay, and second one is bridge rectifier. So let's move ahead. So first rectifier is, that is half wave rectifier. चला मग नोटबुक आणि पेन घ्या. माझ्यासोबत हे सर्किट तुम्हाला लर्न करायचं आहे. सो हाफ वेव रेक्टिफायर. व्हाय इट इज कॉल्ड ॲज हाफ वेव रेक्टिफायर? As we know that rectifier converts AC into DC. AC means alternating one, that is variable, into DC means smooth constant. Okay, so AC means it has positive half cycle as well as negative half cycle. So half wave rectifier means it is the circuit that delivers power at the output side, or we can say power to the load side during only one half cycle of AC supply voltage. ओके, म्हणजेच काय की हाफ वेव रेक्टिफायर हे असं सर्किट आहे की जे आउटपुटला आपल्याला पॉवर डिलिव्हर करतं फक्त एका हाफ सायकलसाठी. सो इन द हाफ वेव रेक्टिफायर, दिस रेक्टिफायर इज ऑन only for one half cycle. So output is produced during only one half cycle and another half cycle is flipped off, means output is 0. Okay, output is 0. So conduction of half wave rectifier circuit is take place in only one half cycle. That's why the name of this circuit is half wave rectifier. Okay, so this is the circuit diagram of half wave rectifier, and you have to draw this circuit diagram during the exam. So half wave rectifier circuit consists of only one diode, okay, one transformer at the input side which is step down transformer, and load resistance at the output side across which we are taking the output voltage V0, or we can say VL, that is load voltage. So this is the main circuit diagram of half wave rectifier. So input to the half wave rectifier is a single phase 230 volt AC supply. As it is rectifier, so it convert that AC into DC. So this is the input. Now या सर्किटची प्रॅक्टिस तुम्हाला करायची आहे. आता हे सर्किट ड्रॉ करा, नोटबुक आणि पेन घ्या आणि तुमच्या डायग्राम तुमच्या बुकमध्ये हे सर्किट ड्रॉ करा. इनपुट साईडला AC सप्लाय दाखवा जो की सिंगल फेज 230 व्होल्ट आहे. देन ट्रान्सफॉर्मर दाखवा जो की स्टेप डाऊन आहे. एक एक डायोड आणि रेझिस्टर RLच्या अक्रॉस आपण आउटपुट घेणार आहोत. सो हे आहे हाफ वेव रेक्टिफायर सर्किट. लेट्स मूव ओव्हर द ऑपरेशन ऑफ half wave rectifier circuit. So its operation is divided into two parts: during the positive half cycle of AC supply, and next one is during the negative half cycle of AC supply. So first is operation during the positive, that is first half cycle of AC supply. This is the circuit diagram of half wave rectifier during positive half cycle. So this is the positive half cycle. Positive input voltage is given to the input side, so that secondary winding of step down transformer, that is the point A and point B. So this voltage is called as secondary winding voltage, that is VAB. So during the positive half cycle of AC supply, point A is positive with respect to point B. So as point A is positive, means diode D is in the forward bias mode, means it starts conducting, means what? Current flows through the diode, that is IL, means load current. ओके, काय सांगितलं आपण आता की जेव्हा पॉझिटिव्ह हाफ सायकल आपण इनपुट साईडला देतो, म्हणजेच अक्रॉस सेकंडरी वाइंडिंग, दॅट इज व्होल्टेज अक्रॉस VAB काय असणार आहे? पॉझिटिव्ह असणार आहे. त्यामुळे डायोड D हा फॉरवर्ड बायसमध्ये जाणार आहे, म्हणजेच तो ऑन होणार आहे आणि त्याच्या थ्रू करंट फ्लो होणार आहे. सो दिस करंट फ्लो फ्रॉम पॉइंट A, diode D, load resistance RL and again to the point B. म्हणजेच होल या सर्किटमध्ये करंट फ्लो होत आहे ड्युरिंग द फर्स्ट पॉझिटिव्ह हाफ सायकल. सो अक्रॉस RL we will get positive half cycle. Okay, means the voltage across secondary winding VAB is equal to the voltage across load resistance RL, that is V0. Okay, so this is the operation of half full wave rectifier during the positive half cycle. So let's move towards the negative half cycle of AC supply. So this is the circuit diagram of when negative half cycle is given at the input side. So this is the negative half cycle, means Vin is negative now, means point A is negative with respect to point B, means secondary voltage VAB is negative. So as point A is negative, means diode D is in the reverse bias mode, means it is in the off mode, it stops conducting, means no current flows through the diode. So as we know that output voltage V0 is equal to I into R. So as I is 0, means current is 0, so V0 is 0, means output voltage is 0. So it offers very high resistance, and the voltage across VAB is, as diode D is in reverse bias mode, so it acts as an open circuit, so no voltage across VAB appears at the load side, means output voltage V0 is 0 during the negative half cycle of AC supply. So what we conclude? It is the half wave rectifier, means it gives the output voltage during only this positive half cycle. So during negative half cycle, output voltage is 0, means this is the input and output waveform. So this is the Vin. During the positive half cycle, diode D starts conducting, D1 is on, diode D is on here. During the negative half cycle, diode D is clipped off, means it is in the reverse bias mode, so it gives the output voltage 0. Vout is 0 for the negative half cycle. And for the positive half cycle, again diode D starts conducting, so we will get output voltage V0. Okay, again during the negative half cycle, output voltage is 0. So these are the input and output waveforms for half wave rectifier. Okay, so during the exam you have to draw this half wave rectifier circuit, main half wave rectifier circuit, and the input output waveforms. Okay, so this is the main half wave rectifier circuit, and then this is the circuit diagram during positive half cycle, then during negative half cycle, and these are the input output waveforms. So what are the applications of half wave rectifier? So first, it is used in battery charger, then power supplies, then it is used for the over voltage protection circuits purpose. Okay, so this is all about half wave rectifier. Then let's practice this half wave rectifier and its input output waveform. The next rectifier circuit is full wave rectifier, in that center tap full wave rectifier. So this is the circuit diagram of full wave rectifier center tap. Okay, it consists of two diodes, that is diode D1 and D2. Then why it is called as full wave? का त्याला full wave rectifier म्हटलंय? Because this is the rectifier circuit, okay, which delivers power to the load or across the RL, that is at the output side, during both positive half cycle of AC supply. Means it is the rectifier circuit. असं रेक्टिफायर सर्किट आहे की जे आउटपुटला आपल्याला आउटपुट प्रोव्हाइड करतं आउटपुट साईडला दोनही हाफ सायकल्समध्ये, दॅट म्हणजेच पॉझिटिव्ह आणि निगेटिव्ह हाफ सायकलला आपल्याला आउटपुटला पॉवर डिलिव्हर होते. सो हे आहे फुल वेव्ह रेक्टिफायर आणि हा टाईप आहे सेंटर टॅप ट्रान्सफॉर्मरचा. सो इथे आपल्याला ट्रान्सफॉर्मर हा सेंटर टॅप्डमध्ये कनेक्ट करायचा आहे. सो हा आहे सेंटर टॅप्ड फुल वेव्ह रेक्टिफायर सर्किट. यामध्ये दोन डायोड्स आपण यूज केलेत, D1 आणि D2. लेट्स प्रॅक्टिस दिस डायग्राम. ड्रॉ दिस डायग्राम फर्स्ट, प्रॅक्टिस इट. ओके, सो अगेन सेम input, that is single phase 230 volt 50 hertz AC input voltage. Then center tap transformer, which is step down transformer. Center tap, that is point O, is the center tapping is given here. Then in the half wave, as we saw, there is only one diode, but in the full wave there are two diodes, that is D1 and D2, and at the output side load resistance RL is connected. So across the load resistance RL, we will get the output voltage V0. So this is the full wave rectifiers. Okay, means this rectifier circuit conducts for both the half cycles, that is first positive half cycle and second negative half cycle. For both half cycles we will get output. Okay, so let's see the operation of this full wave center tap rectifier. So this is the rectifier circuit for the positive half cycle. So during the positive half cycle of AC supply, we have to draw this circuit diagram. Now what happens? Okay, so during the positive half cycle of AC supply, point A is positive with respect to point B. Okay, means the voltage across VAB, that is VAB, across point A and point B, it is divided into two parts due to the center tap. काय झालंय? सेंटर टॅपमुळे ह्या O पॉईंटमुळे जो काही पॉईंट A आणि B आहे यांच्या अक्रॉस जे व्होल्टेज आहे सेकंडरीच्या VAB व्होल्टेज, हे डिवाइड झालं आहे दोन पार्टमध्ये, दॅट इज VAO and VOB. You can say VAO and VBO. Okay, so these two voltages, induced voltages, are equal in proportion but opposite to each other. Okay, so during the first positive half cycle, what happens? point A is positive with respect to point B, means voltage VAO is positive and voltage VBO is negative. So as point A is positive, means what happens? Diode D1 starts conducting, okay, and as VBO is negative, means diode D2 is in the reverse bias, as D1 in the forward bias mode. So D1 is in the forward bias, means it starts conducting, means current flows through the diode D1, but D2 is reverse bias, means it stops conducting, no current flows through the diode D2, but it acts as an open switch, so no current flows. So during the first positive half cycle, what happens? VAO is positive, so current flows from point A, diode D1, then resistor RL, and then back to the O. So current flows through this circuit, this closed circuit, through A, D1, RL and O. So across RL, we will get whatever the voltage across VAO, we will get at the output side, that is positive, and the direction of current flow is same, this one. Okay, so positive voltage at the positive input voltage at the input side, and we will get this positive output voltage at the output side, that is VL or V0. Now during the negative half cycle, what happens? This is the circuit diagram when we are considering the negative half cycle of AC supply. So what happened? Again, during the negative half cycle, this is the negative half cycle, okay. So point A is negative with respect to point B, means voltage VAO is negative and VBO is positive. As VAO is negative, means diode D1 stops conducting, it is in the reverse bias mode, so it will act as an open switch, means no current flows through diode D1. Okay, but as VBO is positive, means diode D2 is in the forward bias mode, so current flows through the diode D2 and direction of current is, that is point B, diode D2, then this like this RL and again back to the O. So current flows like this. So if you observe, the current direction is similar, that is A to B across RL. So we will get positive output voltage at the output side. Okay, means during the negative half cycle of input, we will get positive half cycle at the output. So these are the input output waveforms. This is the input voltage waveform and this is the output voltage waveform. So when first positive half cycle, then diode D1 is on, D2 is off. Then negative half cycle, diode D1 is off but D2 is on, so we will get again positive or half cycle at the output side. Again during the positive half cycle, D1 is on, D2 off, so positive. Then negative half cycle, D1 is off, D2 is on, so we will get output voltage across RL V0 for both the half cycles, that is positive and negative. So this is the unidirectional voltage, that is positive only. So this is the full wave rectifier, will delivers output or power at the output side for both the half cycles. Okay, so this is about the center tap full wave transformer, center tap full wave rectifier. So last and most important, that is full wave bridge rectifier. Okay, so these are the applications of center tap full wave rectifier. It is used in the chargers, then DC power supplies, then industrial control systems and LED lighting systems. let's move towards the full wave bridge rectifier. During the exam, it is most widely used question. So किती वेळा विचारलाय बघा. Make it very IMP. October 22, December 24, October 23, maybe August 22 also. Yes. So full wave bridge rectifier. This is the most important rectifier circuit which is most widely used in the exam, most widely asked in the exam. So what again the definition of full wave rectifier? It is similar to the center tap. It is the rectifier circuit that delivers power to the load during both the half cycles of AC supply voltages, and this is the circuit which consists of 4 diodes. So what is the advantage of this circuit? Why full wave bridge rectifier is invented? So during the center tap full wave rectifier, as we know that it required center tap transformers, means center tapping is necessary in the full wave center tap rectifier, but in the bridge rectifier there is no need of center tapping, and high PIV rating is necessary for the center tapping, but no need to increase PIV rating in the bridge rectifier. So let's move. So these are the main advantages of bridge rectifier. No center tap necessary, no high PIV rating is necessary. Okay, PIV means peak inverse voltage. So this is the circuit diagram of full wave bridge rectifier. Okay, so it consists of 4 diodes, then across output side load resistance, and then center tap step down transformer. So this is the main circuit of full wave bridge rectifier. So this is a diamond shape which is similar to the Wheatstone bridge. Okay, that's why it is called as bridge rectifier. So diamond shape 4 rectifiers are connected to each other. So he diagram draw करताना you have to practice this diagram, and it is necessary to remember few things while drawing this diagram. So काय करायचं आहे आपल्याला? हा डायग्राम ड्रॉ करताना सिंपल आहे. अगेन तीनही रेक्टिफायरमध्ये इनपुट साईडला सिंगल फेस 50 हर्ट्ज 230 व्होल्ट AC सप्लाय, पुन्हा सेंटर स्टेप डाऊन ट्रान्सफॉर्मर, आणि त्यानंतर डायमंड शेप जे 4 डायोड्स कनेक्टेड आहेत, आणि अक्रॉस RL वी आर गोइंग टू टेक आउटपुट व्होल्टेज V0. सो यामध्ये काही गोष्टी महत्त्वाच्या आहेत ड्रॉ करताना, जसं की 4 डायोड्स आपण कनेक्ट करतो आहे, तर जे समोरासमोरील डायोड आहेत, ओके, समोरासमोरील जे डायोड आहेत त्यांची डायरेक्शन आपल्याला सेम ठेवायचे आहे. म्हणजे जसं की आता D1 आणि D2 समोरासमोर आहेत, ओके, इथे दिसतं आहे आपल्याला, त्यांची डायरेक्शन ही सेम आहे अशी, ॲनोड टू कॅथोड, ओके. तसंच डायोड D3 आणि D4 यांची डायरेक्शन ही सेम आहे, ॲनोड टू कॅथोड, ओके. आणि हा जो व्हर्टिकल पार्ट आहे ब्रिजचा, हा आपल्याला इनपुटला कनेक्ट करायचा आहे, सेकंडरी ट्रान्सफॉर्मरला, आणि जो हा हॉरिझॉन्टल पार्ट आहे ब्रिजचे, हे जे 2 पॉईंट, हे आपल्याला आउटपुट साईडला घ्यायचं आहे. म्हणजेच हॉरिझॉन्टल पॉईंटच्या अक्रॉस आपण लोड रेजिस्टन्स RL कनेक्ट करणार आहोत, आणि व्हर्टिकल पॉईंट आपण सेंटर टॅप सेकंडरी वाइंडिंगला इनपुट साईडला कनेक्ट करणार आहोत. सो सिम्पल डायग्राम आहे ही, आणि इथे ग्राउंड दाखवायचं आहे नंतर. सो आता पुन्हा याचं वर्किंग आपण पॉझिटिव्ह आणि निगेटिव्ह हाफ सायकलसाठी बघणार आहोत. सो सिम्पल तुम्हीही लिहू शकता हे. सो काय करायचं आहे, पुन्हा ड्युरिंग द फर्स्ट पॉझिटिव्ह हाफ सायकल वर्किंग आपल्याला लिहायचं आहे, आणि ड्युरिंग निगेटिव्ह हाफ सायकलसाठी. सो फर्स्ट ड्युरिंग द फर्स्ट पॉझिटिव्ह हाफ सायकल ऑफ AC सप्लाय काय होणार आहे, पॉझिटिव्ह व्होल्टेज आपण इथे देतो आहे म्हणजे पॉईंट ए हा पॉझिटिव्ह होणार with respect to point B, means point A is positive with respect to point B, means the positive voltage is here, negative voltage is here. Then diode D1 and D2 starts conducting, means they are in the forward bias mode. Okay, and simultaneously diode D3 and D4 in the reverse bias mode, means they stops conducting. So as diode D1 and D2 starts conducting, means current flows through the diode D1 and D2 only. So current flows from point A, diode D1, then RL, then D2 and then B, जे की आपण नेक्स्ट डायग्राममध्ये बघूया. इथे मी तुम्हाला करंट डायरेक्शन दाखवली आहे. ओके, सो काय दिसतंय, डायोड D1 आणि D2 फॉरवर्ड बायस झालेत म्हणून, कारण VAB हा पॉझिटिव्ह आहे म्हणजे A पॉझिटिव्ह आहे विथ रिस्पेक्ट टू B. सो करंट फ्लोज फ्रॉम पॉईंट A, डायोड D1, देन RL, इकडे नाही जाणार कारण D3 हा रिवर्स झाला आहे. ओके, सो D1 RL, मग इथून पुन्हा D2 अँड अगेन फ्रॉम D2 इकडे पुन्हा जाणार नाही कारण हा आहे रिवर्स बायस. सो D2B, सो करंट फ्लोज फ्रॉम A, D1, RL, okay, then D2 and B. So current flows during positive half cycle through D1 and D2, and D3 and D4 are in the reverse bias mode, so no current flows through these diodes, so they act as an open switches. Okay, so this is the working, means during the positive half cycle we will get the output voltage across RL which is positive, and the current direction is like this, that is positive from A to B, that is plus to minus. So current direction is positive, so across the RL we will get positive output voltage. So what happens in the negative half cycle? So during the negative half cycle, again same diagram, just make one change, that is point A is negative with respect to point B. Okay, means the voltage across A point is negative and across B point is positive. So this is during the negative half cycle. Consider this negative half cycle. Point A is negative, point B is positive. So as point B is positive, means D3 and D4 both are in the forward bias mode. So current flows through these diodes, they starts conducting. Current flows through these D3 and D4, and D1 and D2 are in the reverse bias mode, so they are act as an open switches. No current flows through these two diodes. Okay, so as point B is positive and D3 and D2 is in the forward bias mode, so current flows from point B, then D3, then RL, then again D4 and back to the point A. So if you observe the direction of current, it is again in the positive direction, that is from point A, that is positive to negative. Okay, this direction, similar direction, current direction is similar during the both half cycles. So as current direction is similar for both the half cycles, so at the output side we will get positive voltage, that is V0. Okay, output voltage that is positive. So now these are the input output waveforms. So this is the input waveform V in plus minus AC voltage waveform, and this is the output voltage, that is DC waveform. Output voltage is DC because rectifier converts AC to DC. So during the first positive half cycle, what happens? Output voltage V0 is positive. Okay, means current flows through diode D1 and D2, which is also positive. Then during the negative half cycle, what happens? Diode D3 and D4 is on. Okay, so current flows through D3 and D4, which is also positive. Then again during next positive half cycle, D1 and D2 on, So current flows through D1 and D2, and we will get positive output voltage, and current direction is also positive. During again next negative half cycle, D3 and D4 is on. So current flows through these two diodes, and current direction is similar. So this is a full wave rectifier. So across the output we will get both half cycles output across RL. So applications of this rectifier circuit is regulated power supplies, battery chargers, DC motor drive, solar power systems. So bridge rectifiers is used in these circuits or these appliances. The next one is half wave rectifier and full wave rectifier comparison. So this is the comparison of half wave and full wave rectifier. Very simple, as we know that the number of diodes used in the half wave rectifier, it is only one. Okay, only one diode is required for the half wave rectifier. Then for full wave center tap 2. Then for bridge rectifier, that is 4 diodes are used. Then peak inverse voltage in the half wave, it is a Vm. In the center tap, that is twice Vm, because induced voltages are VAO and VBO. Okay, so twice Vm. And bridge rectifier again Vm. Then efficiency of half wave rectifier is very less because it is a half wave. So it conducts during only one half cycle. So its efficiency is 40.6%. And full wave rectifiers, both center tap and bridge, they are having the highest efficiency, that is 81.2%. Then transformer utilization factor for the full wave half wave rectifier, it is very less, that is 28.7%. Then for the center tap, it is a 69.3%, and for bridge it is again 81.2%. Then ripple frequency. So ripple frequency for the half wave, it is a 50 Hz. For full wave, both 2 into F, that is 2 into 50, that is 100 Hz. Then ripple factor. So ripple factor, that is the ripple contents, unwanted contents. Okay, that shows. So in the half wave rectifier circuit, so ripple contents are more, that is 1.21. Okay, and for the full wave center tap and bridge, same 0.48. Then center tap transformer, it is required or not required. So for the half wave rectifier, it is not required. And then only center tap transformer full wave, it is required. And again for bridge, it is not required. Then RMS voltage, for the half wave, it is a Vm by 2. For both full wave, Vm by root 2. Okay, then next RMS current, Im by 2, then Im by root 2, Im by root 2. Then DC or average load current, that is Im by pi. Here twice Im by pi, again twice Im by pi. Then maximum DC load voltage, Vm by pi for half wave rectifier. Then for full wave, twice Vm by pi, twice Vm by pi for bridge. Then applications. Half wave rectifier is used in batteries, chargers, over voltage protection circuits, etc. Then center tap is used in DC power supply, chargers, LED lighting systems. And bridge is used in DC motor drives, power supplies, UPS, solar system, etc. Then circuit diagram for both, for all of, that is half wave, full wave bridge. Then input output waveforms for half wave, full wave, and center tap and bridge. Okay, so these are the comparison points. So this is all about rectifier circuit. So if you like this rectifier circuit series, then do like, subscribe and share it more and more. आणि तुम्हाला आणखी काही या बेसिक इलेक्ट्रॉनिक्स सब्जेक्टशी रिलेटेड नोट्स हव्या असतील, देन यू कॅन कमेंट ॲट द in the comment box. Okay, then I will try to provide it as soon as possible. Thank you so much.